Now let us talk about the transformation of functions. How do we define transformation, and what's the relation between functions and their transformations? Transformation of graphs. So we're learning new terminologies, everyone. We need to learn these terminologies. We need to memorize them. When you're explaining math, precalculus, we need to be able to identify the correct terminology. Vertical shift. Here's a question. The first one is y equals to x squared. The second one is y equals to x squared plus 4. The next one is y equals to x squared minus 4. So what are the similarities between these three graphs? We already know that well. Here we have a parabola. This guy, the blue graph, is also the parabola. And this is a green parabola for a quadratic function. What are the similarities between these? As you can see, here we have a vertical shift in these graphs. Your original graph, your parent graph, was x squared, and then you shifted that 4 units up. It has a vertical shift. You see change in y value, not x value. X values are the same, 0 and 0, but your y is now 4. Well, what if I take this red graph and shift it downward? As you can see, I have a shift downward. You see there is a change in the y value. My y is -4. Now just check these graphs. Here you have your parent function, quadratic function, x squared. Now you're adding 4 to the y value. You're not changing x. You're subtracting 4 from the y value. This is your y value, x squared. You're adding 4 to your y value. You're subtracting 4 from your y value. And we see vertical shifts in our graph. So vertical shift. Let y be equals to f of x. If we add, subtract a constant, a value from y, then we have vertical shift. What do I mean by that? Just take a look at your function. Here you have your function, y equals to, for example, x squared. Now, what I'm going to do, I'm going to add a constant to my y value. I'm going to create y equals to x squared plus 3. Addition 3 changes my x squared. X squared is y value. It shifts the graph 3 units upward. So now you have your graph plus 3. I'm going to shift 3 units upward. It seems like I'm just taking the same function and just moving that upward. So this is y equals to x cubed x squared plus 3. Now, what if I subtract a number? Y equals to x squared, now minus 3. Let's see what happens. I'm taking this parent function, and shifting that 3 units because of negative sign downward. So here you have your parent function, the same function, just shifted downward. So here you have y equals to x squared minus 3. This is called vertical shift for the graph. So what I'm going to do, I'm going to take my x squared, and now instead of changing y, I'm going to directly change my x. So I'm going to put that in parentheses, go next to x minus 3, and close up the parenthesis. Well, guys, look at this. This is my parabola, x squared. If I subtract 3 from x itself, I shifted the graph to the right. So subtraction gives the same graph shifted to the right-hand side. Now let us take a look at this case. Y is equal to x plus 3 to the second power. Well, if I add 3, I'm shifting the graph to the left-hand side. Take a look at this. Negative 3 and 0, 0 and 0, and then I have 3 and 0. Wow. So if I change my x, I see a change on x-axis, horizontal shift. Let's take a look at our board. So horizontal shift. Very good. Let y be f of x. This is the function that you have. If we add, subtract a constant to x, if we add or subtract a constant to x, then we have a horizontal shift. Horizontal shift. So again, let us go back to our quadratic function, x squared. This is my x squared. My happy function, always smiling. This is y equals to x squared. Now what I'm going to do, I'm going to add, subtract constants from x. So what do I have here? I have y equals to x plus 3 to the second. X plus 3 to the second. What do I have? Guys, if you find the X intercept for this graph, to find X intercept, remember that we said y equal to 0. This quantity must be 0. X plus 3 to the second is equal to 0, or x plus 3 is 0, or x is negative 3. You have a shift to the left-hand side, negative 3. So this guy is my quadratic function. The parabola shifted to the left. So this is x plus 3 to the second power. Adding, shift the graph to the left. Subtracting, shift the graph to the right. So now y equals to x minus 3 to the second power. How to assure that I have a correct horizontal shift? to find x-intercept. Set y equal to 0. Y is 0. It means that x minus 3 to the second is 0. This quantity must be 0. So x is positive 3. So as you can see, you have to shift your graph horizontally to the right-hand side. To the right-hand side. This is your graph that you're going to see here. So this is x minus 3 to the second. X minus 3 to the second power. Very good. Very well. Let us go back to our Desmos. Let's see what are our observations here. Let's take a look at these graphs. So the first graph is going to be graph y equals to square root of x. So this is square root function. This function starts at 0. We cannot plug in any negative number inside the radical. Why is that? Because the index is 2 and the domain must be 0 or any number larger than 0, positive numbers. Now, what do you see here? Y equals to negative square root of x. Do we have mirror image of the red graph with respect to x-axis? What did I do? These are your y values, positive y values. If I plug in 0, I get 0. If I plug in 1, I get 1. If I plug in 4, I get 2. Now I'm multiplying my y by a negative sign. Multiplying y by negative sign. My y, they were originally positive. Now all of them are negative. All of my y values are negative. So what did I do? I multiply y by negative sign and I get reflection with respect to x-axis. Let us take a look at our board. So we talked about vertical shift. We talked about horizontal shift. So let us summarize them here. Vertical shift. Y equals to f of x plus a constant. Horizontal shift. We are changing our x. Y equals to f of x plus minus c. Now reflection with respect to x-axis. Reflection with respect to x-axis. As you can see, to get reflection with respect to x-axis, we are changing our y value. Y becomes minus f of x. So if we have graph of y equals to, for example, square root of x, this is the graph of square root of x. If I multiply y by negative sign, minus square root of x, minus square root of x, what do I have? I have reflection with respect to x-axis. So multiplying your y by a negative sign gives you reflection with respect to x-axis. This is my x-axis, my horizontal axis, and these two are mirror image of each other. Let's take a look at Desmos again. Now, I want to change this by multiplying that, the x by negative sign. Well, see what happened. Hey, now I'm changing all of my x values to be negative. Take a look at this. My original x values, they were all positive because of the domain. Now, if I multiply my x by a negative sign, I have negative x values on the left-hand side of y-axis. So as you can see, you have reflection with respect to y. Reflection with respect to y gives us negative x values. So reflection with respect to y-axis. Well, what do we have here? We just saw that if y equals to square root of x as a square root function is given to us, multiplying my x by a negative sign, which is y equals to square root of minus x, gives me this graph, which is reflected with respect to y-axis. It means that these two graphs are mirror image of each other. If I just fold this paper with respect to y-axis, they are mirror image of each other. We have reflection with respect to y-axis.